Next we're going to move into chapter 8. If we have time, we'll go back to chapter 7, but really chapter 8, chapter 10, 11, and 12 are going to be more important for what you're going to need to know than chapter 7 or chapter 9. So chapter 8 is going to include the Pythagorean theorem, which you should already have some knowledge about, but also trigonometry. And trigonometry is the thing that scares geometry students. But there's one simple rule that if you learn it will make trigonometry really, really easy to do. But let's go ahead and start with Pythagorean theorem. The Pythagorean theorem, remember, states that a squared plus b squared equals c squared. Now this is going to apply if we have a right triangle and if we call c the hypotenuse of the right triangle. So this will always work. Then Pythagorean triples. These are going to be really important for you to memorize because you're going to see these on the SAT. Whenever you're confronted with a problem on the SAT that includes a right triangle, the answers will always, or 99.9% of the time, be Pythagorean triples. Because remember that when you're taking the SAT, you're given about a minute to work out each problem. So you've got to have shortcuts to be able to get to solutions. So the shortcuts that they're going to give you are the Pythagorean triples, but you have to recognize them. So a Pythagorean triple is simply this. It's three integers that create the sides of a right triangle. So normally, whenever we do right triangles, the majority of the time, any right triangle is going to be a combination of either square roots or decimals. But when we have Pythagorean triples, we have only integers. So if we do 3 squared plus 4 squared equals 5 squared. 3 squared is 9, 4 squared is 16. So you add those together. 9 plus 16 is 25. Well, 5 squared is 25 as well. 25 equals 25. So that means that you have a Pythagorean triple, 3, 4, 5. Then you also have 5, 12, 13, 7, 24, 25. And then one that I've never seen actually used on the SAT, but you may want to memorize it just in case they decide to put it on there, is 8, 15, 17. Now, what else do you need to know about Pythagorean triples? They're actually proportions as well. So what we can do is we may not just have 3, 4, 5. You could have 3 times 2, 4 times 2, 5 times 2. So another common one that you're going to see is the 6, 8, 10. 6 squared is 36. 8 squared is 64, 10 squared is 100, 36 plus 64 is 100. So that would be another Pythagorean triple. So you can multiply these by the same number and they're always going to be Pythagorean triples. So if we do these by 10, 30, 40, 50 is also going to be a Pythagorean triple. It's always going to work out that way. Now that you understand Pythagorean triples, let's actually move on to a problem. And in this problem, we're given that we've got a right triangle with sides, or with vertices A, B, and C, and sides of 20 and 21. What it wants us to do is find out what is the length of the hypotenuse C. So what we're going to do is just apply the Pythagorean theorem. We've got side A is 21, so we're going to square it. Side B is 20, so we're going to square that. And we're going to set it equal to side C, so we get C squared. Now, you just have to do the multiplication on this. 21 times 21 is 441. 20 squared is 400, and that's going to equal C squared. Add these together, you get 841 is equal to C squared. And if you take the square root of both sides, then what you're going to get is that C is equal to 29. So what we can see is that we've got another Pythagorean triple here. The Pythagorean triple of 20, 21, 29. Now don't worry about memorizing 20, 21, 29 because I've never actually seen it before outside of this book. You want to make sure that you memorize these here, 3, 4, 5, 5, 12, 13, and 7, 24, 25. And then also realize that you could see other Pythagorean triples that are just multiples of this. So 6, 8, 10 is a common one, and then 10, 24, 26 is a common one, and then 14, 48, 50 would be another one that they might throw at you. For problem number 2, we're going to again apply the Pythagorean theorem. In this case, we're given the hypotenuse in one of the sides, but we're asked to find what is the length of the second side. So again, all we're going to do is take the Pythagorean theorem. A squared plus b squared equals c squared, and we're going to plug in the information that we know. So we know that one of the sides is 8, so we're just going to put that in for a. So a squared plus x goes in for b squared equals 20 squared. And then we're just going to solve this. So 8 squared is 64 plus x squared equals 400. Subtract the 64 and you get x squared equals 336. Now what we've got to do next is go ahead and take the square root, and then we're going to get x is equal to the square root of 336. But this is a little sloppy. We might want to try to clean this up a little bit. We don't want to take this down to a decimal, because once we take it down to a decimal, we take it from something that is completely accurate, the square root of 336, to something that is not going to be completely accurate, which is going to be a rounded decimal. So I prefer you to keep all of your answers as square roots. Now, if you need to, or if you can, go ahead and reduce them. 16 and 21 both go into 336, so we're going to get x is equal to the square root of 16 times 21. Then the square root of 16 is 4, so we get x equals 4 square root of 21. This is going to be the simplest radical form. This is where you're going to need to leave your answer at. So we know that if we have a side of 8 and a hypotenuse of 20, the other side is going to be 4 squared root of 21. In problem number 3, we're actually given a word problem. And we're told that we've got this seesaw. So thing you go up and down on when you're a kid, but it's being used for a dog course. And what they want to do is they want to find out if this is part of the triangle that makes up the seesaw, then how far are the dog's paws off of the ground if the seesaw is parallel to the ground. So we can use the Pythagorean theorem to figure out what is the height of that triangle. So what we'll do is go ahead and set this up. 26 squared, we'll call that x, plus x squared equals 36 squared. And then what we're going to get for that is 676 plus x squared equals 1296. Then we're going to subtract the 676 from both sides, and we're going to get x squared equals 620. Now take the square root of both sides, and you're going to get x equals the square root of 620. But again, we don't want to leave this as a square root that could be simplified. So we need to figure out, are there any perfect square roots, or are there any perfect squares that go into 620? Well, seeing that 620 ends with 20, we know that 4 is going to go into it, because anything that's divisible by 4, or any pair of numbers at the end that's divisible by 4, means that the entire thing is going to be divisible by 4. So 4 is going to go into this 155 times. And so what we're going to have left is, once we take the square root of 4, it's going to be 2 square root of 155. This is the answer we want to use, because that's going to be our most accurate answer. If we were to take that into a decimal, then we're going to have to round our decimal off somewhere, and then we're going to have an inaccurate answer because it's been rounded. In problem number 4, we're going to take the converse of the Pythagorean theorem and apply that. So that's going to be, if we're given a set of numbers, can we then determine if we've got a right triangle? So if we have a right triangle, we know that our a squared plus b squared is going to be equal to c squared. That's the key, that's going to be equal. So we're going to go 85, 84, and 13. So we need to arrange these the way that they should be. So we'll call 13 our a squared, we'll call 84 our b squared, and we'll call 85 our c squared. So we're going to need to go ahead and calculate those. So for 13 squared, we get 169. For 84, we're going to get 7,056. And for 85, we're going to get 7,225. So now we just need to add up the left side to determine if it's equal to the right side. 169 plus 7,056 is going to be 7,225. 7,225 equals 7,225, and so we do know that this is going to be a right triangle. This is a Pythagorean triple, and we've got a right triangle. Now, to determine if you've got an acute or an obtuse, what we're going to do is we're going to start off with c squared being on the left side. So if c squared is equal, then we get a right triangle. If c squared is greater than the sum of a squared and b squared, then you're going to have an obtuse. And just think about it like this. If you're looking at c squared first and you have a greater than symbol, then think about that as being like an obtuse triangle. The open end is greater. Then if c squared is less than the sum of a squared plus b squared, then you're going to have an acute. So again, this time we've got a less than sign, so think about less than being acute. So if we go into problem number 5, we're given 6, 11, and 14, and we're asked, would those make up an acute triangle, an obtuse triangle, or a right triangle? So we're going to go ahead and arrange these the way that we need to. So 6 squared plus 11 squared equals 14 squared. Now if you want to go ahead and write it the other way so that you have c squared on the other side, you're more than welcome to do that. So we can write 14 squared equals 6 squared plus 11 squared. This is going to give us those equals, greater than, or less than that we need in order to determine what we've got here. So 14 squared is going to be 196. 6 squared is 36. And 11 squared is going to be 121. So if we add 36 and 121, we're going to get that 36 and 121 together is 157. And so that means 196, the c squared side, is going to be greater than 157, which is the sum of a and b. Okay? And so that means that we've got an obtuse triangle because we ended up with c squared is greater than the sum of a squared plus b squared.